Hello and welcome back to Luna. I'm Mick, we're playing Stationeers. Now we are back on our Luna base now. I'm not going to be building the Luna base today. Today I'm going to be rebuilding our printer logistics system. Now previously I have had a couple of goes at it. So I think my latest version on that's version 4. I've had a rethink of that because there's a couple of problems with it and it does take up a fair bit of resource. At the moment, I will control each of the printers with a chip, and each of those printers will ask for a restock from a vending machine whenever it runs out of ingots. That means if I have two printers requiring ingots at the same time, they'll both request ingots at the same time, and the vending machine can't give out two ingots at the same time. So it causes some confusion. So I figure, how about if I take the vending away from the printers and control it, instead of from 4 different chips, control it from one chip from the vending machine end. That might be a way of simplifying it all. And because I've now simplified the code for each of the printers, can I run the printing of each of the printers off the one chip? So 4 printers off one chip. So that'll be the challenge that we go for today. Previously I've been limited by the number of pins, but now that we've got the direct access to devices, I can now put as many devices as I want onto a single chip. So previously I've had 4 printers and 1 vending machine, so there was 5 chips to control it all. I want to control it all now from 2 chips. Maybe 1 chip if I can, but we'll swallow that horse when we get to it. So I'm going to have to get 4 printers to start with, because at the moment I don't have 4 printers. So empty out these things and grab me other printer, which is down here. Right, so I'll shift these around. Make sure all my precious don't run away. Right, I'll put them somewhere safe and I shall move these printers around. Okay, that's the printers all back in place. They've each got a stacker. Now I just need to cable everything up again. So we will need to cover the data and power for all of these things, because I should want to use the actual dial on the stacker there to set out how many printers, how many items I want printed. We get there eventually. So we need to hook up all of them, and how far have I got? You and that's it. Good me. I've done it all. Right, so they're all hooked up. Now I need, of course, a stacker for each of the printers, which I think I've printed out. A sorter. They've got stackers. I need a sorter. So we need a sorter each. They will need to come, I'll put them downstairs, they'll need to come up to the input side of the printers. So if I line them up, now we have sorters and logic sorters. I will use the logic sorters. Logic sorters can sort, well, they have a stack, so they can sort pretty much by themselves, and I don't need to control them as much. I can set that into the wall a little bit. Yeah, why not? So we're putting down the logic printers. Logic sorters. Wow. First time recording a video. And I shall need a vending machine which is going to deliver all our ingots. So I just need a basic vending machine, which is you. I'll probably best not put that one in the wall. Need more. Oh, right. That's right. I need 2 vending machines now to build a vending machine, because the small ones only take us one vending machine thingy. So I'll need to get some stuff back in my printers. Now I shall need my 2 vending machines to build a large vending machine. I can fit there. Yep, that'll do us. And I need some plastic sheets to finish that one off. Yeah, there we go. Oh, okay, and no welder. Right, we switch it on before we start. I might actually grab my stacker from here as well. That can be handy for splitting up the ingots going into the vending machine. Put you two there. Right, we have got all of that, but now we just need to cable it all up. Easy. Right, now we should have power. Now we do have power. Excellent. So I just need to get them all shooted now. See, that's my auto lathe up there. So this will be deciding what goes into the auto lathe. That's my electronics printer there. This decides what goes into the electronics printer. And this one decides what goes into the pipe bender. And this one goes into whatever's required by the tool bender. Tool bender? It's not a tool bender. You don't bend tools. Well, you shouldn't bend tools. And we just need a bypass to go through them all. So that should be good. And I've run out of chutes. Now I have my computer. I shall need some housings. Got 5, that is plenty. Well, if I'm going to get it down to 2 chips, 5 is very, very plenty. 2 chips. And that's what we're going to do it in. We're going to do it in 2 chips. Maybe 1. We'll see. I've run out of cables now. Well organised show. Yep. So I should put maybe over here, put in the important button. Because that has more importance than the other buttons. And, oh, yes, and probably a console so we know what the thing's actually doing. See there, grab a hash display and some windows. Ah, there was some more cables. Don't panic, I've got cables. Right, we now have our display hooked up. Previously I had 4 displays hooked up. Now I only need 1. Now I'll need to program 1 chip to handle all the ingot vending. So it will need to know what is in each of the printers. That's 4 items it has to know. It'll have to know each of the 4 sorters, 8 items. It'll need to know vending machine and the reset button. There's 10 items it has to know there, but you know, I've got 16 registers there, so I should be able to handle that. I'll stop running around in circles and start going. I shall want to grab a chip. Well, there's definitely nothing on there. I might grab my old code. Yes, with version 4, printer logistics. So I should grab you. And we shall rework this. Now, this is the one that normally controls the printer. The main part of what I want is where it's checking the ingots to decide what ingot is needed by the printer, because that's a lot of typing. So I think I'll keep that and just reuse it. But the rest of it is pretty much got to go. We will still need to know the printer, but we'll need to know all 4 printers. I don't need to know the stackers. I'll need to know 4 sorters, the vending machine and the button. I don't need the export because we are not doing accounting on what it's been done. So on stackers we don't need. Check if the ingot's arrived. I'll need to do that, but I think I can do that at the end. Right, so let's just clear all this off. Check the button. So I'll need to check the button. So let's just actually take this down to the end. So I remember to do it all. Check the button. Oops. And I shall need to check if the ingot's arrived. Copy you. Put you down the bottom there. So it'll basically, instead of having to keep checking for it to arrive, it'll just wait for it to arrive at once. It'll just be 1 printer at a time, which should make it a bit easier. Now we can send out a command to find those devices on there. I mean, of course, the circuit has to be, data on the circuit has to be isolated from the rest of the base. There has to be only one vending machine and one button, or it won't work. I suppose I could set it by pins. It's not like I've got to set 5 chips anymore. It's only one. Get all the printers. I could put them each into registers and switch between. How do I switch between if I put them in registers? I might just put them into the stack. Yeah, I might put them into put the printers and the sorters into the stack, and then I can just call them from the stack and just run the same bit of code. Okay, so I will need to find them all. So I shall load batch. No, try again. We shall alias the vending machine, which is no longer optional, to, R10. And I shall load batch into the vending machine. I need a device hash, which is F1 the vending machine. Is the vending machine. I'll grab you. Oh, I'll just take the number. It says there what it is. Just take the number. That'll make it easier. Vending machine. The logic type is the device ID. No. Reference ID. Reference ID, and our batch mode, there should only be one of them. So it doesn't really matter what we put in there, but we've got to put in something. So average. Now that should return the reference ID for the vending machine and place it in there. So now whenever we want to load from vending machine, it has the reference ID for us and it should work. We shall do the same with the button, which is not optional. So you can go to R11. 11, try again. Oh, come on. Come on, editor, work a bit better. And we shall put you into there from the, whoops, from the button. Button is the important button. Right. So once again, it'll search the network to find the vending machine and find the button. So I don't have to assign them the pins, and I don't have to tell it what the reference ID is for those, because it'll find it itself. It's in the setup. We'll only run this once. So I'll just do it at the start of the code and then we're good. Now they, I think, are all we need to find there. The other ones are the printers themselves. So once again, we shall, a few more lines of code there. Similar sort of thing, we shall copy that one there. So load device into R0, we shall need the auto lathe. The auto lathe. I might grab these ones here. That should be easier to read. So we should say hash. Oops. Structure auto lathe. That just makes the code a bit more readable. As soon as it runs the code, it'll change that to the hash number, but it just makes it a little bit easier for the humans. I just wrecked the wrong one, didn't I? Well, lucky I've still got that one there. Right, into R0, the hash of the auto lathe, the reference ID and the average, and then I shall just push that to the stack. So I'll need to do, then I'll need to find the sorter as well. Now I do have multiple sorters there, so I can't just load batch for the sorter. I'll have to name it, give it an individual name to make them all have their own, well, name. So we shall load batch named into R0. It'll be the hash of the sorter, the logic sorter. Sorter, logic sorter. We're using logic sorters. So grab you, structure, logic sorter. I should start to know these things by now. And into there. And we want the name hash now. So this one will be for the auto lathe. So I guess it'll just be auto lathe sorter. I'll put a lot of thought into that. So hash. Lathe. Waste tank caution. Sorter. Oh, thank you. I should have pressed the pause on that, shouldn't I? That might have helped. Right, we can do that. Auto lathe sorter. Now we will need to know, we're looking for the reference ID, reference ID. I had all the right letters in there, just in the wrong order. And the average, because once again, there should only be one by that, and I shall push that back onto the stack, R0. Now I need to do that for each of the printers. That'll be a bit repetitive, but yeah, let's go. Okay, so we now have the auto lathe printer found, auto lathe sorter, electronics printer, electronics sorter, hydraulic pipe bender, and pipe sorter, tool manufactory, tool sorter. They have all just been pushed into the stack one after the other. So we shall need to be able to draw them back out. So we have used R10, R11, and okay, so we need to know what ingot we've got, or what ingot we're trying to find, which is R12, and our old input port number, so we know when the imports have arrived. Now I shall also need to know, because I've put the devices into the stack, I'll need to pull them back out of the stack and assign them to a value or a register. So I shall need to alias the printer to 14 and alias the sorter to 15. Is that all I need? Well, we'll find out as we go. I'll probably need a reset in there. Reset. Right, so we are setting our ingot to the dummy ingot that we've created there called no request. We don't have to set our sorters. We'll be using the stack pointer to get things out, so we shall move a stack pointer, set our stack pointer to 0. Now when we start, now I need to extract the printer from the stack. So I shall need to pop out the printer and pop out the stack. What do I call it? Sorter, not stackers. Sorter. So that will increment it. Next time it comes back to start, it'll pull out the next printer and the next sorter. Okay, so now we want to check ingots. Now this is the main thing here. This looks into the printer, which we have just pulled out of the stack, and it will find out what's in there. So we are going to, yeah, we'll yield, why not? Branch, if it's not set, well, it's no longer optional, so I don't need that column in there. Now, if it's open, go back to the start, we move to the next printer. That's fine, that's good. Branch, the ingot is not equal to no request. So, well, that shouldn't really happen. But we'll use it there as a safety. It shouldn't really get there. Yeah, because we're just going all the way through. We're not looping this anymore. So what this will do is it'll go through, it'll check in the printer if the contents requires iron. If it requires more than 50, put it in there, or if the recipe requires more than 50, put it in there. And it will just go through, check each ingot. If it requires it, it'll set the ingot to iron or copper or whatever. So if it requires iron, it'll set it to iron. If it requires copper, it'll overwrite that and say it requires copper, and so on down the list. But the important thing is, once it comes to the bottom, it'll have, if it requires an ingot, it'll come out there with that ingot. Just the last one. It's got to go through multiple times there, so we'll just go through and get the last one. If nothing's required, it'll get down here and say, we don't need any more ingots. Go back to the start and it checks the next printer. So if we're still here, we have, in ingot, we have stored an ingot that we want to find. So we then set to our, we say we want to dispense it from the vending machine. Then we want to immediately put into our sorter. We want to put into the stack of the sorter, say, we want 1. So next execution by count 1. So once we put in a command to say, just do the next instruction 1 time, and followed by the prefab hash of what's in ingot. So it'll say, if we need iron, it'll say, for 1 time, get that sorter to send 1 stack of iron ingots back into the system. Right, so now we don't want to go back to the start from there. Now we want to go into a wait loop, basically until okay, jump back to the start down there then. We want to go into a wait loop until the ingot has arrived. So this is where the old way of doing it is the printer was still trying to count the number of prints it was doing while it was waiting for an ingot to arrive. This one doesn't have to. Now it just has to go into a wait loop until it's arrived. I guess we need to, I suppose we first got to find out what the old count was, which I think we had up here. We did have an old import. Yes, that's right. It's the import count we're looking for. So I shall load from the printer. Well, let's actually load into the old import. From the printer, we want to know the import count. Yes, that'll do. So it will then, it sort of says, what's the current import count? And then we should go into a yield and say, we shall load it again. Load into R0 from the printer, the import count, and then just say branch equal if the new import count R0 equals the old import count, then nothing has happened. So let me just go back to check ingot arrived. So just keep doing that until the import count on the printer goes up by 1. Right. When it has, it means the ingot's arrived, so we can go and check again, or check the next printer, or whatever we need to do from there. Check the button. We've got to check the button. Right, so in that loop, while it's waiting, if for some reason it doesn't arrive, I need to check the button. Right, so it's basically a case of just load into R0 from the button the what is it? Button, important button. That's just this setting. Open. Activate. Setting. Let's go with setting. Setting. Right, and just say branch equal. So if the button equal to 1, we've pressed the button. Let's bump back up to reset. Right, the button hasn't been pressed. Keep waiting. Once the ingot arrives, go back to the top. That should be right. Okay, so if we go back to reset, we've reset the stack pointer, reset the ingot, and go again. That should work. How do we know when it's reached the end of the stack? Wait a minute, we're popping. Oop. Okay, forget about the bit I said on this one. Yeah, that's not going to work. We shall need to go, so we popped 8 items in there. Because when we say pop, it'll actually find the item and then go reduce the stack pointer by 1. So if we set the stack pointer by 0, it's going to pop that out and try and take it to -1, which is not going to work. So I'll have to say we've got 8 items in there. So we'll set our stack pointer to 8. And as we come back to start, I might have to say branch equal to 0, stack pointer to reset. So if the stack pointer is to 0, go back to reset, which will set the stack pointer back to 8. Right, now it pulls the items out of the stack in reverse order. So I need to actually pull out the logic sorter first and then the printer. So if we say that way, that should work. Right, so we clear our ingot, we set our stack pointer to 8. If our stack pointer's got back to 0, we've got to the end of the stack, set it back to 8. If it's not, all groovy. Pull out the sorter, pull out the printer, check the ingots in the printer, and yeah, that's why I didn't want to rewrite that one. It's a long one. It will set the ingot as requesting onto the DB housing. If it doesn't get down there, it won't reset that. So let's go back up to reset, and we shall save to the DB housing ingot. Sorry, my bad. Save the setting to ingot, which will be no request at that stage. If it hasn't found any, no ingots needed in that printer, move to the next printer. Otherwise, order it, wait for it to arrive. Once it arrives, go back and check again. That should work. Oh, dude. Yeah, we've got solar storms now. Oh, that's trippy. Oh, that is very cool. The Quicksilver on the... Anyway, it's not what we're here for today. So that is very, very, very cool. How much power am I getting? 2.7 kilowatts. Okay, that's pretty cool. Oh, the Quicksilver is very cool. That looks so trippy, but yeah, very cool. What do I want to do? I wanted to change my tank. All right, back in a minute. Let's export that into there. Put you in. Now I should just be able to switch it on. And it gives me an error. Device not found at 102. I knew there was too much code there written. 102 is sorter. You didn't find oh, I haven't named my sorters. Ha ha ha. Yes, that's right. I need to name my sorters, like I said. So you are the auto lathe sorter. You are the electronic sorter. You are the pipe sorter. And you are the tool sorter. Now pop you again. Okay, we've got a green light this time. Now it is not flashing, so it's not reading right, and it says on the housing there that he's waiting for an ingot. So I should be able to use the vending housing. Why not? I should be able to use my little display up here to tell me what it's trying to send out. If I put you onto the vending housing, that should be giving a hash value. It's trying to put out steel. Probably because I've got all of these closed. And do I have a fat stack of steel? I do. I've got a fat stack of iron and not a great deal else, but let's see how we go. So that is set to 50. I chuck in a heap of them. And chuck in a heap of you. Be a good test for the button there. Does my button code work? Now, if I push the button, it wipes that out. It has just sent something off. Now it's wanting silicon. So that ended up where it was meant to go, wherever that was. Come on, who got it? You got it. Okay. So that went to, yes, because the last item on the stack was the tool printer. So the first one it checked was the tool printer. So how about if I open you up? It should ignore that one now. You've got nothing in you, so I'll empty you up as well. Okay, now if I push the button, it should ignore that one. And it should be dispensing something to the next one, which is the... I still want silicon. Okay, fair enough. Right, I might have to go do some mining. Back in a minute. Rightio, after an awful long time of mining and smelting, I have a rather disappointing stack of ingots. Well, yeah, a lot of them are fat stacks, but yeah, it's once you've melted down a heap of stuff into fat stacks, it doesn't look that impressive. But anyway, I've now got the ingots I need. I can now switch on our printers. Now, we were looking for gold. I think I put gold in there. Push the button and we go for steel. We want to put steel in one of the printers. I did have steel in there. Yep, now we're putting gold in. Which, maybe I didn't put gold in there. I mean, I just did a whole heap of smelting there and I got a heap of gold and I didn't put it in the actual vending machine. Well, there's a fat stack. If I set you to 50, I'll get a heap of stacks of gold in there. Okay, try again. How about push the button right now. Out comes gold. It'll go to where we need it. We want copper now. Copper's gone. And iron. Iron is going. Silicon's been dispensed. I don't know where these are going to, but they're certainly getting there. Gold for another one. So you're fully stacked. You still need iron. Whoop. You still need stuff. We're still putting out iron now. But that's the thing. I don't actually know where they're going at the moment. My old system there, it had a little display above each printer saying which printer wanted what. But not anymore. We're still spitting out ingots. We've run out of silicon, have we? Okay. Well, I need to put in a fat stack of silicon. Yeah. A couple of short stacks there. They can go in there. That'll be fine. Now a fat stack of silicon. And push the reset button. And we've got silicon going out. Is that going to... You've got nothing yet. Oh, the switch is open, so it's leaving you alone. Nothing's coming out the other end down there, so it's all going to somewhere. I just put in a heap of silicon. Something's not right. Okay, why isn't it getting... Oh. Ha ha ha. That's why it's not getting to you. Because I forgot to put the chute back on again. Right, that should work better now. Right, copper and iron. Yes, you only have 48, you should have 50. And it stops putting stuff out because everything should have their minimum quantities in there. Which they do. Now you're open, so you've got nothing there and nothing is being requested. As soon as I close that, it should now spit out the minimum ingots into you as well. Excellent. Away we go. Was that not enough steel? Okay, 36 steel. It wants 50, so it requested steel again. Oh, excellent. If I print out, pick something which has requirements of other stuff there, I need a reagent processor. Well, that doesn't even have much then, does it? Try oven. Automate oven. That's Constantan and solder, which we don't have. It should now request it. That's the solder. And that's the Constantan. And it's all happy again. Right, so it seems to be restocking all of my printers okay. All of the printers, all of the printers are being restocked via the one chip now instead of having 5 chips for it. Now my vending machine doesn't ask for a minimum stock of anything, so it's not going to warn me when it's running out. It only tells me when it's running out when it tries to deliver something it doesn't have. So yeah, you could say that's a bit of a problem, or you can say, you know, toughen up. But if I get a jetpack, you don't have those things. You got Waspaloy, which I haven't put in there yet, have I? Whoops. Yeah. We've got it in there now. Don't worry about it. And more Astraloy. Gotcha. Boom. I've got that. It's got to be careful now if I pop it onto the next item there, it'll reorder the stuff for it. Yeah, want Constantine for that one. So, maybe I do want to put a stacker on that one and decide how much it wants. But now comes the next tricky part, because I have got to get each of these printers, well, at least these 3 of them here, to use the stacker to count how many items have come out of it. I got a new jetpack. Oh, that one's
jetpack critical.
Easy enough to put stuff into it. That's better. That can go in the storage. Right, so I need to do the next step of this one. I might grab a drink and something to eat first. Okay, so we have the ingots being dispensed properly. So can we put any embellishments onto it? And yoink. Like for instance, we do have our, I've got it in my pocket, haven't I? We do have our sorters here. They are using power, required power 5. Okay, so I was going to say, should we bother switching them off? I'm going to go with no, because I could quite easily switch them off when they're not in use, but for the sake of 20 watts, who really cares? It's probably not worth it. Okay. So in terms of embellishments, no. So now the trick would be to get the printers to print out right number of items. I think the way we've handled the printers can be done the same way. So we want to go with what we've got here. We have got a way for it to find the printers and get their reference ID. You could just go up there and manually grab the reference ID and push that, get rid of that line and just push the reference ID. Same as sort of. Now, if you had multiple auto lathes, you would have to do that because you wouldn't be able to find it via these ones here because they'd both be the same. So you would have to sort of push. You can say you can set up multiple auto lathes. It's just that you would have to manually put in their reference IDs and their matching sorters. So that can be done. The trick is, as you add more printers, you've got to remember to update this number. So can I actually get it to remember that? Take that step out of it. It doesn't really matter if you're not doing anything. So after it's gone through, the stack pointer should be pointing at the last item in there. So if we define the maximum stack to be just stack pointer, then I should just be able to say down here it is the maximum stack. So if you do add in more printers there, you don't have to remember to update that now. Does that work, or do I have to do a like max stack -1? Yeah, it doesn't work. The end. Oh, not a number. Okay, so that didn't work. Alias Emacs stack to 10, which I haven't used. And we shall say max stack there. No, you're still not working. Son of a... Oh, because I haven't set it. Okay, only some max stacks to there. And we shall move into max stack the stack pointer. Export. Now you should have 8 in there. You do now. Right, thank you. I don't know why I couldn't define that. Oh well, I couldn't define it. Let's just say that's right. Export you, put you into there, and you are properly running. Right, so now if I add in more printers in there, it will automatically update the size of the stack, so I don't need to do that anymore. 99 times it won't matter, but for the 1 or 2 people who do want to add more printers in there, that'll make it easier. Right, other than that, it is pretty much a straight through bit of code. It just runs all the way through, no complex looping. The only loop is when it's waiting for the ingot to arrive. And that's pretty much it. Well, that's pretty simple. So now we want to make the printers print out a set number of devices. I would like to use basically the same format. So if I grab that and export you onto that chip, well, I don't really want all of it there. I just want the first setup bit we have there, where it finds the printers, and I'll have to change them to stackers and get rid of all the rest of it. All right, well, let's get rid of all this stuff then. And that will put our auto lathe, our stacker. Change them to stackers. Do you want to change them to stackers as well? So the stacker. Okay, that's right. We've got a forward and reverse stacker, haven't we? And they're both called stacker. Let's say it's the second one that I'm using.
Filter low.
I might actually grab you and yeah, we'll say we'll grab that one. We'll say we'll define that one. Define the stacker as dash u. I think I'm using the reverse ones. So then I can just say yep, u. Oops. Stacker, and the tool manufacturer we're not having. Right. Okay, on these things, I also need to know what the last output count was as well. So I will need to know what the last output was from this, because we're going to use the output or the export count on the printer to measure how many of the items we've printed. So we shall need to say when it starts printing, we'll need to check it and then count off all the items there. And as it goes up, compare it to what it was before we started printing to what it was. So I've got to remember what it was before we started printing. So I'll need to store that for each of the printers. Okay, some debugging still needed on that one. I didn't remove anything, did I? All right. So I need to say, well, basically I need to store another value with each of these. I could store them in the registers, but if you want to add more printers in, that could stuff things up. I'm just going to write it back into the stack. So if I just push another value in there as a space, as a usable space, push 0 and push 0. And that should give us our maximum stack there. Get all that right. So we need to know our old export count there, our printer and our sorter. So our old max import, we're going to have to push back into the stack. So reset, we set stack pointer to the top of the stack. And I guess we just start by, well, we're at the top of the stacks. We'll have to pop them back in reverse order. So we shall pop the old export. I shall pop the stacker. We shall call that a stacker. And we shall pop the printer. Right, so we do all of that. And when we jump back to the start, it'll pop the next export value stacker printer until we get to 0. Branch equal to 0. If the stack pointer equals 0, you cannot pop any more values out of there. So go back to reset and go back to the first printer or the last printer and count backwards depending on how you look at it. Right, so we've got our printer, export and stacker. So I will want to look to it and see if the printer is active. If the printer is active, we'll be counting the prints. If it's not active, I want to store the export value into the old export. If it's not printing, we want to reset the counter. If it is printing, we're going to use the counter. So I should load into R0 from the printer. Yeah, let's go with activate. And it's an export count we're looking for. Printer activate. So if the printer is currently active, the branch not equal to 0. So if it is active, go to count prints. And we'll put something down here. Prints. Right. So if it's not active, I want to load into R0 from the printer the export count. Actually, I want to load it into old export, don't I? Old export. And I've got to put it back into the value up there, which is not where the stack pointer is pointing. Well, let's just... that's a solar storm. Now, I was going to export that and see if it worked. Oh, it looks to be. Okay. We'll take that. Right, so it seems to be reading through all the printers okay. So it is... So the old export goes to 9. I want to insert it into 8. Our stack pointer will go to 9, 8, 7, 6. So I need to add 2 to the stack pointer and poke the value in there. So we shall say add, can be 2 or add 3? Well, I'll say add 2. If it works, I'll leave it in there. If it's not 2, then I'll edit that out and pretend that I was always right. Add into R0, it will be the stack pointer plus 2 or 3. We shall see. And we shall poke in location R0 the old export value. Old export. Right. And then move to the next printer. So I should jump back to the start from there. Okay. Export. Oh, still working. Nice. Still working. Okay. So 2 was right. 2 is the number of the count, not 3. Right. So we have... That is now reading the export count from the printer and poking it back into the stack. So if it is printing, we have the old export stack on the printer. So we should want to know how many we've got to print. We want to know what the current export value is and what the old export value is. And if the current export minus the old export is less than what the setting is on the stacker, keep printing. Okay, so we need load into R0 from the printer export count. Now we need to subtract R0 will equal the current export count minus the old export. Right, so that's how many have currently been printed. So we shall branch less than, so we haven't printed enough. So if R0 is less than, I'll need to load the amount we need on the stacker, don't we? So load into R1 from the stacker, the setting. So branch less than, if the number that we have actually printed is less than the number we want, which is R1, Go back to the start. Go check the next printer. Keep going. It's all cool. If it's equal to or greater than, we need to stop it. So save to the printer, activate 0. So stop printing. Then go back to the start and look at the next printer. That seems a little simple, although we were trying to simplify it all. And there's no yield in my program. Probably on the reset. On the reset, we can yield. So I'll check all of the printers and then do a yield and check all of the printers every game tick, which is what we want it to do. Okay. Export you and see if we've made a mistake. It's still liking it. Nice. Right. Is that working? So let's just give me 2 of them. 1, 2, and it stopped. Oh. Oh, ho, 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 ho. Nice. You, cables. Give me 4 of them. 2, 4, and stop. It worked. So give me 4 of them, and you give me 2 of them. You stopped. Sweet. I'll just put you into there. Oh, nice. Now I shall say, if the printer is not printing, we will write the export in. I can also say if the printer is not printing, it might be because it's switched off. So I shall load into R0 from the printer on, and I should save to the stacker on R0. Confirm that one. Export you. Going. Now, if I switch you off, stacker switches off too. Noise. How much power do they use? Require power 50. Right, so it's not like the sorters there, which are 5. This is 50. So they are worth switching off. These things are 100 while they're idle, so yeah, try and switch them off. Probably could switch that off. That's probably the biggest power burner of it all, is just the display. I suppose I'm glad I'm only using 1 of them now instead of like 4. That'll save me a lot of wastage. Now, what problem have we got with you? Device not found at 99. That is looking for a vending machine. Why do you know why have you lost what the vending machine is? And because I've overwritten it, haven't I? You stupid head. Go to 9. Now that's why I should put all my registers and stuff together. 10, right. Our max stack goes to 9. Export you. Now we're all working again. Okay, well that's pretty much my printer logistics done. So that will vend all of the ingots we want from the vending machine. It's actually driving that from the vending machine in now instead of driving that from the printers. So all of the printers, all of the restocking is done from a single chip, which means we had very simple code, which just goes all the way through, no fancy looping, and which meant once we took all that out of the printer housings, it meant that there was hardly any code left in the printer housings. So that's that all done. Why didn't I do that the first time? That is just so much easier. Well, I suppose that's why we learn and get better at things, because we get better at things. Anyway, that is my new printer logistics. So it is very versatile. You can hook up as many printers as you like to it. Of course, it won't automatically find them. It's set up at the moment to automatically find them if you've named them right, but and you only have a few there. But you can, just by grabbing the device ID, which we have there, reference ID, if you put in hexadecimal at the top, but we also have a reference ID down the bottom, which is in decimal, just add them into the stack. And the same for the printers, and you can have as many duplicate printers, as many as you like. Just add them all in and it will all be controlled from the one chip. Oh, that's pretty cool. I like that. Anyway, I'll call that done. I think that's a huge improvement. So I'll probably clean up the code a bit and document it a bit better, and then I'll publish it. I'll use it for a little bit too and make sure it's not full of bugs. But we'll see how we go. So that's about it for today. So till next time, happy building. See ya.